This is Java OCA Unit 3 Lecture 2 on conditional statements. In this lecture, we will talk about weird if statements, ternary operators, and switch statements. So the goal of this unit is to practice evaluating conditional statements like the kind that you will encounter on the OCA exam. This means we will be working with poorly formatted conditional statements, statements with poor use of brackets, and statements whose code is indented with the intent to deceive. Again, the OCA exam wants you to demonstrate that your brain is trained like a machine and that you will be able to identify when Java code will cause a compile time or a runtime error. So we'll begin with if statements that don't use braces. When braces are not used to enclose the if statement block, then only the first line of code after the if conditional belongs to that block. So consider the example shown on line 8. Here's line 8. Line 8 is the only line of code that belongs to the if statement on line 7 because there are no braces. So line 9 will execute regardless of whether line 7 is a true or a false condition. So the output for this example is lion calories equals 2,000. Even though the animal changes its name here to lion from swan, it is not part of the if, so it will execute regardless. And the animal stored here is now lion, and the calories is still 2,000, because at this point, animal was not lion, it was swan, so it didn't change the calories from 2,000 to 2,500. And hence, your output. As previously stated, when braces are not used to enclose an if statement block, then only the first line of code after the if conditional belongs to the if block. In the example shown, line 9 is not part of the if block. Therefore, line 10 will cause a compile time error because the else part does not have a direct connection to the if statement. This example does not compile. So here's our if statement. This is our if block, and this is just another line of code which disconnects the else statement. Else statements must be connected or directly follow if statements. Otherwise, you get a compile time error. Here we'll see an example where the indentation of the code is deceptive. So if you consider the code shown here, what is the output as a result of executing this code? And the answer is here, grade is an A, grade is still not an A. The reason is because there are no braces containing the else block of code. Therefore, line 11 will execute regardless of whether the else part is active or not. So again, this is the only part that is considered the else block because braces were not used, and this will execute every time. And then we have nested if-else statements, and if the formatting is not correct and the indentation is poor and there's no use of braces, it can be difficult to see which else belongs to which if. So when the if-else statements do not use braces or proper indentation, then you must work from the innermost if statement and pair it up with the innermost else statement, and you keep working from the inside out. Much like you would in math with parentheses inside of parentheses, you would work from the innermost parenthesis and work your way out, and that's what needs to happen here. So we see that these two are paired up. This if belongs to this else, and then next is this if gets paired with this else, and we keep working our way out, and that is how it is done. We can see that if we restructure the code, this is what it would look like. And when we have well-structured code with braces, it becomes much easier to evaluate the nested if-else statements. So it is up to you as a test taker to restructure the code or to make the proper links between the ifs and the else so you can evaluate it correctly. Next up is the ternary operator. The ternary operator is a condensed if-else construct. It is an easy way to declare and initialize a variable based on a condition. So the format of the ternary operator is you have to have your declared type, and then your variable name. The equal sign is necessary, and then you need a Boolean expression or a Boolean variable, followed by a question mark, and the result you want to use if the Boolean is true, followed by a colon, and then the result you want to use if the Boolean is false. So in this program, we have a string taxi equal to passengers less than 4. This is a Boolean expression. So if we go up to the program, we see that passengers is equal to 4, not less than 4, so this is false. Since it is false, it will not set taxi to a regular taxi, but to an extra large taxi. And if you run this and you execute it, it will print out XL. So we'll continue with the ternary operator, but the only difference is instead of using simple strings or values as the true result or the false result, I've put methods in their place. So here we have a type again, and this time the type we're using is a double. Our variable is total due, so we're talking about money. And our Boolean expression is now just a variable. The variable is called discount, and we see that discount holds either true or false. If it's storing true, then it will run the discount price method. If it's storing false, it will run the regular price method. And we see that the discount price method gives them a 12% discount and then charges 5% tax and rounds it to 2 places and returns a value. If it uses the regular price, it doesn't discount it, it charges 7% tax and then rounds it to 2 places and returns the value. So to summarize the ternary operator, you must start with a condition. That condition could be an expression that returns true or false, or it could be a variable that stores true or false. And then that follows with a question mark, and then your expression or your method call if it is a true output. And that follows with a colon, and then your expression or your method call if it is a false output. You must start with Boolean, must contain if and else parts, must be assigned to a variable, meaning there must be an equal sign here, and your variable that this is going to go to, and the data types must match. Here we have switch statements, which are conditional control structures that are used to replace if-else-if constructs because they improve readability. However, switch statements have some restrictions. The switch expression is limited to the following types. The switch expression can use primitive types, it can use wrapper classes of the primitive types, or it can use a string type. Second, the case values must be compile time constants. This means that the case values can't be changing values, they have to be a constant value. And third, for reference types, the switch argument cannot be null. So the switch argument would be up when we start the switch statement. It can't start off as null. So down here, this would throw a runtime error. It would compile fine, but when you go to run it, you would throw a runtime error. So let's look at an example. The program shown uses an int variable called tax status with a series of conditions to determine the correct tax status for a tax filer. The switch expression is tax status. So if this were a reference type, we said this cannot be null because at this point it would throw a runtime error. Since this is a primitive type or a wrapper class of a primitive type, it is fine as long as there is no null. The case values are 1, 2, 3, 4, and default. So we see that 1, 2, 3, 4 are not variables that can change their values. They are constants, they are fixed. And then default is that if none of the above are matched, it will use the default output. Default is an optional construct. It does not have to be implemented in your switch statement. Third, notice how each statement uses a break. That means after we execute this, it will cause a stop here and leave the switch statement. If I did not have this break, and case 1 were true, then it would print every case after 1 all the way to the end if none of these had breaks. So the break statement is important to stop after that case if that's how you want it to be executed. If you needed it to execute everything that followed, you would leave the break statement out of your switch cases. And as I already explained, the default case is optional, and I've given you an explanation as why you may or may not want to use the keyword break. These are both optional elements, but you have to figure out if you need to implement them to get the behavior you want out of your switch case. So here's a coding task for you. You can pause the video here, write up a quick code in BlueJ, see if you can get it to do this. You have the task, which is to write a program that asks the user to enter their birth year. It'll evaluate their birth year by using modulus division by 12, and the modulus gives you a remainder. If the remainder is 0, it's the year of the monkey. If the remainder is 1, it's the year of the rooster, and so on and so forth. You will use a switch case to represent each of the outputs for mod 12, and the solution, meaning my code, will be displayed on the next slide when you unpause and continue with the video. So here is the way that I structured the program. Yours might be slightly different, but as long as yours is using the modulus division and producing the correct output, the year of the monkey, year of the rooster, and so on and so forth, and you did your program using switch case and you've implemented it correctly, great job. Let's continue. So let's see what happens when we have a switch case with no break. And you can notice that I set the variable count to 2. So when it starts going through these cases, it'll say, nope, not 0. Let's look at the next case. No, it's not 1. Let's look at the next case. It'll say, yes, it is 2. Let's print out 2. But because there's no break, it will continue to print out and execute each line of code thereafter. And we see the output shows us 2, 3, and I can't count that high. This is the end of the lecture. Watch it again, take notes, complete your skills check, email me with questions.